Following list. List 1 contains a DMA processor status word, that is PSW processor status word, and a daisy chaining handshaking. List 2 contains priority interrupt IO transfer CPU asynchronous data transfer. So DMA is a direct memory access. So this is related to IO transfer. DMA is related to IO transfer because DMA is meant for doing IO. Because IO is of three types: so programmed IO, interrupt initiated IO, and direct memory access. Processor status word, it is one flag register, set of flag register, which mentions the status of the CPU, status of the processor at any moment. When arithmetic operations are done, it needs to be updated. It is in the CPU register. So processor status word is a CPU register. Daisy chaining is a method of the priority interrupt. Daisy chaining, in a priority interrupt, we use this daisy chaining technique. Handshaking is asynchronous data transfer. That is P2, Q3, R1 and S4. That is option B is the right option here.
This question: two relations R and S on a set A, on a non-empty set A are given, and it is given that both R and S are reflexive relations, and 6 statements are given. We have to identify the correct statement from the given 6 statements. In order to solve this problem, first we have to know what is reflexive and what is irreflexive relation. Let R be a relation on a set A on A, then for all x belongs to A, x comma x should belongs to R. This is the condition for reflexive relation. For all x belongs to A, x comma x should not belongs to R. This is the condition for irreflexive relation. So here it is given that both R and S are reflexive relations. That means all the diagonal elements are present in the relations R and S. So here, let us take one example. Let R be, let A be 1, 2, 3, 1, 2, 3. Then let R be a it is reflexive. It is given that R is reflexive. So here 1, 1 should be present, 2, 2 should be present, and 3, 3 should be present, and the rest are optional. Like 1, 2. Let us say 1, 2, 2, 2, 3, 3, 1. So this let this set be relation R. Let S be even S is also reflexive relation. So here 1, 1, 2, 2, 3, 3 should be present, and the rest are optional. So let us say it also contains 2, 1, 3, 2, and 1, 3. So if you see the first statement, R union S is reflexive. Here union of R and S. Here both in the resultant relation, all the diagonal elements are present. Then it will be reflexive relation. So here this is correct. Second statement says that R intersection S is reflexive. Here R intersection S also contains all the diagonal elements. That means 1, 1, 2, 2, 3 comma 3, etc. So here R intersection will also be reflexive. Here R minus S is reflex. Third statement is R minus X is reflexive. This is not true. Why? Because the elements that are present in R and which are not present in S gives will not contain the diagonal elements. Here R minus S will be, these diagonal elements will not come. So here 1 comma 2, 2 comma 3 and 3 comma 1. This is the R minus S. So here this is not reflexive. Why? Because here diagonal elements 1 comma 1, 2 comma 2, 3 comma 3 are not present. So this is not reflexive. So here third statement is false. And R minus S is irreflexive. So R minus S, this is, so here we got R minus S as this one, and we know that for all x belongs to A, x comma x should not belongs to R. This is a condition for irreflexive. Here diagonal, not even a single diagonal element, either 1 1, 2 2 or 3 3. So these are not present. So we can say that this is irreflexive relation. So here fourth statement is true. And fifth statement is S minus R is reflexive. So here S minus R also false. Why? Because S minus R will not contain the diagonal elements. So here S minus R will be getting S minus R as elements that are present in S and that are not present in R. So here we will be getting 2 comma 1, 3 comma 2 and 1 comma 3. 1 comma 3. So these are the elements in S minus R. So here diagonal elements 1 comma 1, 2 comma 2, like 1 comma 1, 2 comma 2, 3 comma 3, so on are not present in S minus R. So we can say this is not reflexive. So here fourth statement 5 is wrong. Statement 6 states that S minus R is irreflexive. We got S minus R as 2 comma 1, 3 comma 2, 1 comma 3. In S minus R, there will not be any diagonal elements. So we can say S minus R is irreflexive relation. So here statement 6 is true. So here statements 1, 2, 4 and 6 are true. 3 and 5 are false. So here correct option is option A, 1, 2, 4, 6.